A rogue black hole is a black hole that is not located at the center of a galaxy and does not belong to a binary black hole system. These black holes are thought to have formed in the early universe and have been wandering through space ever since. They are believed to be relatively rare, but scientists have recently suggested that they could be more common than previously thought. Rogue black holes can be difficult to detect because they do not emit any light and they do not have nearby matter to interact with. However, scientists have proposed several methods to detect rogue black holes, including looking for their gravitational effects on nearby stars and searching for the radiation emitted by any matter that may be falling into the black hole. The exact process of how rogue black holes are created is still not fully understood by scientists. However, there are several proposed theories on how they may form. Runaway black holes. These are black holes that are ejected from the center of a galaxy due to the gravitational interactions with other objects, such as stars or other black holes. They can be formed in the core of dense star clusters, or in the center of galaxies where there is a concentration of massive objects. Primordial black holes. These are black holes that are thought to have formed in the early universe, shortly after the Big Bang. They could have formed from the collapse of extremely dense regions of matter, or from quantum fluctuations in the very early universe. Binary black hole mergers. When two black holes in a binary system merge, the resulting black hole can be kicked out of the system with high velocity, becoming a rogue black hole. Intermediate mass black holes. These are black holes that have masses between 100 and 100,000 times that of the Sun, which are thought to exist but have not yet been detected. They may form from the collapse of massive stars or from the merging of smaller black holes. It's worth noting that, currently, rogue black holes are considered to be relatively rare in the universe, and their formation process is still under investigation. Scientists are still working to understand the properties and behavior of these mysterious objects. Rogue black holes are extremely dense and massive objects that exert a strong gravitational pull on anything that comes too close. They can pose several dangers to nearby matter, including tidal forces. The gravitational pull of a black hole is stronger on one side of an object than the other, causing the object to be stretched and distorted, a phenomenon known as tidal forces. These forces can be extremely powerful and can easily tear apart any object that comes too close to a black hole. Event horizon. The event horizon is the point of no return around a black hole beyond which nothing can escape. Crossing the event horizon means being sucked into the black hole and being crushed by the immense gravitational forces. Spaghettification. Objects that get too close to a black hole can be stretched into long, thin shapes, similar to spaghetti. This is known as spaghettification. Accretion disk. Matter that falls into a black hole forms an accretion disk, a swirling ring of gas and dust that can emit intense radiation. This radiation can be dangerous for any objects that come too close to the black hole. Keep in mind that rogue black holes are extremely rare in our galaxy, and the chances of an object coming close enough to a rogue black hole to be affected by its gravity is extremely low. The chances of a rogue black hole making it to Earth are considered to be extremely low. Rogue black holes are thought to be relatively rare in the universe and are not thought to be present in our galaxy. Even if one were to exist within our galaxy, it would have to pass through the dense interstellar medium and would likely be captured by the supermassive black hole at the center of the Milky Way long before it reaches the solar system. Additionally, the probability of a rogue black hole passing through the solar system at the same time that Earth is present is also extremely low. It's also worth noting that even if a rogue black hole were to pass close to Earth, it would not necessarily pose a danger to us. The gravitational pull of a black hole is strongest at its event horizon, and as long as the Earth is outside of it, we would not be affected by its gravity. Even if a rogue black hole were to pass through the solar system, it would likely be traveling at a very high speed and would not linger long enough to have a significant effect on the planets. In short, the chances of a rogue black hole making it to Earth are considered to be extremely unlikely and poses no danger to us.